Chemical equations and stoichiometric calculations. Check out chemical equations and stoichiometric calculations. First of all, we should know something about the important characteristics of a chemical equation. A reactant plus reagent gives under certain reaction condition. It can either be heating or cooling, whatever it may be, or certain under certain pressure, etc. That gives the product. Along with that, you will get some byproduct also. Byproduct. This is the main product and byproduct. This is called chemical reaction. And for a chemical reaction, let me consider AB, another reagent CD. CD. Um, just a minute. I'll share it. Is it visible now? Got it? Okay. So we have a reactant AB and the attacking reagent CD. Now, the chemical bond between these two elements that participate in this molecule, that is, that form the molecule. So the chemical bond is cleaved here. So the cleavage of old chemical bond, right, to form a new bond. For example, A is divided from B so that A can combine with the C. Similarly, B can combine with the D to form another product like this. So, cleavage of old chemical bond and formation of new chemical bond is called, what is that? Chemical reaction. If I got a chalk piece like this, when I break it, I cannot say this is a chemical reaction because I am not breaking any chemical bond involved here. I am just breaking the physical force of attraction that exists between the molecules, right? So when the physical bond is broken, that leads to physical properties. Chemical bond is broken means that leads to chemical properties. Do you understand? For example, I have got an iron piece. When I melt it, it is molten, it becomes a liquid. What I am doing here, I am just breaking the physical bond existing between the iron molecules or iron atoms here, right? But similarly, in the case of water, ice is molten and it forms as liquid. Then it is further converted into gas by boiling. So these are all physical reactions. These are freezing point, melting point, boiling point. All are called the physical properties only. Whereas this type of cleavage of old chemical bond and formation of a new chemical bond that results what chemical properties only. And in fact, these chemical reactions, they are of a different types as you have studied in your lower classes, like combination reaction, precipitation reaction, and then neutralization reaction, redox reactions, etc. Displacement reaction, metal displacement reaction, double displacement reaction. So we have studied variety of chemical reactions. But our idea of dealing the chemical reaction here is to analyze stoichiometrically. So we need to do some calculations based on stoichiometry. What is this stoichiometry? Stoichio means element. Stoichion means element. Metron means to measure. So it deals with the stoichiometry means it deals with the calculation of masses, right? Calculation of masses, sometimes volume also, sometimes pressures also. So we are calculating, for example, I have got X reactant and Y another reagent or reactant that combine to form, say that is a L product and M product like that. So in that case, what could be the mass of this L based on the mass of X? Do you understand? So based on that, we need to work out the stoichiometry because they have got some definite proportions. Okay, so based on that only they will react. So we can exactly calculate what amount of a product can be obtained. In the case of, for example, let me consider ethanol. What is the formula of ethanol? C2H5OH. When it is combustion means that is you are burning in presence of oxygen. So when you burn any organic compounds, what happens? It gives carbon dioxide and water. Okay. So by burning X amount of what do you call this ethanol that combines with oxygen. So when it is burned, it forms carbon dioxide. So Y amount of carbon dioxide would have been released. And we are interested to calculate is that amount of water also. Do you understand this? So in this case, we need to that is adopt a certain general steps for all types of stoichiometric reactions. Okay. Now let us consider step one. First of all, we must write for stoichiometric calculations. When I put SC, stoichiometric calculations. So what we are supposed to do, we have to write down the balanced reaction first. Okay, please note down. And as a second step, write the stoichiometric coefficients. Stoichiometric coefficients. Coefficients means that is a molar coefficients. For example, that is when you got C2H5OH here, let me consider we had to balance this reaction. We are already aware of balancing the chemical reaction, so let us balance. So this is a 3CO because O2 plus O. Okay, and this is a 2 plus 2, 4, and you can call it balance is 6, so 3. Okay, now you can check 2 carbon, 2 carbon. So you can adopt that ERP method also for this, that about which I already discussed with you, right? Do you remember? So here the carbon is the number, I mean, a carbon is there, hydrogen is there, oxygen is there. So carbon, how many carbons are there on the left? That is on the reactant part, two. And on the other side, two. So it is balanced. And what about hydrogen? Six. Here, three twos are six. And then oxygen, one, three twos is seven. One plus six, right? And what about here? Two twos are four plus three, seven. So that is also balanced, right? So first of all, we must ensure the balancing of chemical reaction that I have done. Okay. Second is we have to set up the stoichiometric molar coefficient. That is molar coefficient. So these are the molar coefficient. That is 1 mole of ethanol reacts with 3 moles of oxygen to form 2 moles of carbon dioxide and 3 moles of water. So this is the stoichiometric that is coefficients. That is molar coefficients of the balanced chemical reaction. So do you understand? So what we are doing here, we are balancing and achieving the molar coefficients, okay, of balanced reaction, right? Okay. Third step. In the third step, that is, we have to convert moles into required quantity. So convert mole. We have got only molar coefficient, that is moles. You have got the moles here of the balanced reaction. Like in this case, that is, you have got 1 mole, 3 mole, 2 mole, and 3 mole. These are all theoretical moles, right? So convert this mole into the required quantity, that is weight. Okay. And then, so these are all theoretical. So you are obtaining the theoretical weight. Do you understand this? And then, as a fourth measure, that is fourth step, you have to write the given weight, that is given data. They would have given in weight or volume, so that should be taken as the experimental weight. Okay, take down. Right, given weight, that is given weight of each reactant or product. And then now we need to calculate, that is, we have to calculate the moles here. That is the weight asked. What is the weight? Now, let me adopt this method. Let us do one simple example here. And when you work out these relations, we can have different types of relationship, like mole-mole relationship, mass-mass relationship, and volume relationship, then mass mole and mole mass relationship, or mass volume relationship. So likewise, we have got five types of what these calculations. So you can make it as a sketch note. Take down stoichiometric calculation. What is SC? I'm simply writing as abbreviation. Stoichiometric calculation, where we have five types of what calculations. So in the first case, we have, that is, mole-mole relationship. So mole can be represented as N. So N relationship. That is nothing but mole-mole relationship. Second is mass-mass relationship. You can put weight also. So mass-mass relationship. Okay. And the third one is, that is, mass mole relationship. That is weight mole relationship. Okay. Or it can be, that is, mole mass relationship. It can be reverse also. NW. Right? Do you understand this? And you have another relation, like, that is mass volume. That is weight volume conversion or volume relationship. Otherwise, it can also be volume mass relations. Okay, got it? Similarly, we have volume relationship. Okay, so one, two, three, four, five. Now let me take the first one, that is mole relationship. I will explain about this. Okay, and what is mole, and how you can write down the mole very simply, like a mathematical equation. How can you do? First, let us discuss mole relation. What is N? Weight by molecular weight. Take down. If it is a molecule, okay. If it is an atom, then you have to consider weight by atomic weight, okay. So what is W? That is a mass or weight in gram, and molar mass, that is capital M. This is molecular mass. Molecular mass, that is given in, what is the unit? Gram. Very good. Gram per mole. And what is the atomic mass? A. That is atomic mass. That is also given in gram per mole atom here. Okay, so gram per mole. And similarly, you have um, N that represents number of moles. Take down number of moles. Got it? In fact, you can count the number of and molecules also. Number of moles is N. Number of molecules and number of atoms can be calculated. You have another equation. For example, you have got an equation, you can put N dash is equal to N into capital N. Take down. And what is this N dash? That represents the number of molecules. Okay. You can even calculate the number of molecules based on this relation. And you know very well N is nothing but number of moles, right? And what is the unit for this? It is simply mole. And what is Avogadro's number? N. That is 6.02 into 10 power 23 per mole. You have to say some quantity per mole. That's all. Okay. And similarly, you have another equation also. For instance, N double dash. What do you mean by double dash? That represents number of atoms. Okay, number of atoms. So to calculate the number of atoms, what you can do, now you have N dash is equal to, okay, N dash is equal to, what is that? N can be replaced by W by M. So W by M into N. So this is the formula. Okay. And in this case, we have to consider the atomic weight. So N double dash is equal to weight by atomic weight into Avogadro's number. So do you understand this? Okay. So that makes the difference because we need to, that is, consider the atomicity also. I will explain that one also. For example, when you represent any element, put X. On the left subscript, you can mention the atomic number. On the left superscript, you can mention the atomic mass or mass number. Okay. On the right superscript, you can write the charge or as oxidation number. And here you can mention the atomicity. Do you understand this? Okay. So H2SO4, let me consider this H2SO4. See, the atomicity of hydrogen in H2SO4 is equal to 2 because I have put at the subscript. Do you understand this? And what is the atomicity of sulfur in sulfuric acid? Consider this. That's it. 1. Atomicity of oxygen? 4. Atomicity of sulfuric acid? You can add everything. Get add. So, 7. Do you understand? Okay? Yes. Right. And what is the atomic number? Atomic number is represented by Z. So Z is nothing but number of proton that is equal to number of electrons. Is it not? Yes. Mass number is number of protons plus number of neutrons, where we don't include the number of electrons because their mass is negligible comparing to these two masses. So this can be called a neutron number also. N means number of neutrons means neutron number. For example, you have got uranium uh, 92, 235. Now, what is the neutron number? How you can calculate? We can make use of. For example, yeah, 92. Yes. So NP instead of NP, you can write a Z. So it is A is equal to Z plus number of neutron. So from this you can beautifully calculate. So number of neutron is equal to A minus Z. So you have got both A and Z. So what is A? 235 minus this 92. So that you can say this is 143. So the neutron number of what? Uranium 92,235 is 143. So likewise you can work out. Now let me come back here. So the I hope now you are very clear with the mole concept. Is it not? Right. Now, what we are going to do is we have to calculate based on this reaction. Let me take up this, we'll take the same ethanol here. Okay. Let me write separately so that it will be comfortable for you. Now, see, so first we have to write down the balanced reaction. That is step one. So you can always put some space, leave some space here so that you can start writing from here. So CH3, CH2, OH. Is it not? That is nothing but C2H5OH ethanol. And we have balanced 3 moles of oxygen to give 2 CO2. So you have 3 O2 and then as product 2 CO2 plus 3H2. Got it? Okay. Okay. Right? Shall I proceed? Ah, now, so this is the balanced reaction. So as a next step, what we are supposed to do, this is step number one. Step number two, we have already achieved the balanced reaction. So you can write down the number of moles here. That is molar coefficient or the stoichiometric, that is coefficient. How many moles of ethanol? One. Here, how many moles of oxygen? Three. So what does it indicate? 1 mole of ethanol is burned in 3 moles of oxygen to give 2 moles of carbon dioxide and 3 moles of water. Got it? Okay. Now, yeah. So you know already that is N is equal to what I already explained. That is W by M. Is it not? So based on that, you can obtain the W. So N into M is equal to W. Got it? Okay? Yes. So now let us go ahead with the third step. So in the third step, we are going to calculate the weight. And this weight is nothing but the theoretical weight. And this is also theoretical number of moles. That is as per the stoichiometric equation. Okay? And for which you should know the molar mass also for each of this. I would suggest you can put molar mass also here so that that will be convenient for you. So put molar mass, put M. What is the molar mass of C2H5OH? Carbon 2, 24, hydrogen 6, oxygen 16. So 36. 36 or 46? 46, right? So you can put 46 gram per mole. What about this? This is 1 mole. And oxygen 32. Is it not? And what about this one? Carbon dioxide, carbon 12, 44. 44. What about water? 18. Okay. Now, as a fourth step, what you are supposed to do, you can calculate the weight now. This is the theoretical weight, is it not? You know very well weight is nothing but N into M, right? So you can just multiply this so that you are able to get 46 mole. This is per mole. So mole inverse mole cancel. So you are able to get the weight. What about this? 3 into 32. How much? 96. Here 88. Here 3 8s are 24 balance 2 and 3 plus 2 5. So 54. Okay. Now as a fourth step, now we are interested to calculate the, so note down the question here, take down the question. So what they have asked is, they are just asked the number of moles only by giving the number of mole also. So in that case, let us worry about moles only. Let us not worry about the weight. Do you understand? Now the question says, take down the question. How many moles? Write down. How many moles of carbon dioxide? How many moles of carbon dioxide? How many moles of carbon dioxide will be obtained? Will be obtained. Okay. When the condition is given 0.274 mole of ethanol, that is C2H5OH, is burnt. Okay. Right. Now, what is given here? We know the theoretical mole. So this is the theoretical mole I highlighted here, right? And we have already done the combustion of ethanol, right? So we achieved the balanced reaction based on the statement, and we know the theoretical number of moles here. Now they have given, this is the experimental value. That is, you can put Ne, that is the experimental value or given value. How much mole of C2H5OH? C2O is given 0.274 mole. Okay. So when this mole is burned, how many moles of carbon dioxide? They have asked this. So just put X here. Now put a box, right? Okay. So what you are supposed to do is very simple. You take the number of moles divided by number of what? Number of theoretical moles divided by number of experimental moles will be always a constant. Do you understand? So 1 mole divided by 0.274 is equal to 2 mole divided by X. You can make it as a ratio here. What is that? 1 divided by 0.274 is equal to 2 by put X. That's all. Got it? Okay. So find out X. So X is equal to what? X can be brought here, and this is 2 into 0.274. Now what is the value? 0.548. That's all. So 0.548 number of moles. This is the value asked. That is number of moles of carbon dioxide released is 0.55, 0.548 mole you can put. Okay. So this is called, what is that? Mole-mole relation. Are you able to follow? Now you could have guessed. See, similarly, you can have mass relation also. And that is why this is called mole ratio. This is called mass ratio. Do you understand this? Okay. So let us have another problem based on mass ratio. So what we have discussed here, mole ratio. Now we are going to discuss the mass relationship. That is mass ratio. So we have checked this one, mole ratio. Now we are going to discuss the mass ratio. Okay. Take down. Second question. Calculate the calculate the amount of water as gas produced by the combustion of 16 gram methane. Okay. Now let us take up. See, first of all, we have to write down the balanced reaction. So how to write down the reaction? Calculate the amount of um, water is produced by the combustion of methane. I already told you combustion means burning organic compound in presence of oxygen. So you can put what is organic compound? CH4, methane. It is burnt in presence of oxygen to give. Definitely it should give carbon dioxide and water. Okay. So all are in gaseous states. Shall I proceed? Now let us move to the next step. What is the next step? You have to find out the molar ratio. Is it not? N. Theoretical mole. 1 mole. And before that, you have to balance this reaction. So CH4, so you can put 2. Is it not? And here put 2. That's all. Okay. Now it's perfectly balanced. So 1 mole. What about this? 2 mole. Here, 1 mole. Here, 2 mole. Right? Okay. And what is the molar mass? What is the molar mass? 12 plus 4, 16. And this one, 32. This one, 44. This is 18. And then, so now, be 64. Which one? Isn't it 4, like 2 into 2? No, no, no. We are calculating just the molar mass. We take only the molar mass. Then you have to put weight, that is mass. Okay? This is molar mass, right? This is molar mass, molecular mass. I am just taking only molecular mass, and based on that I am multiplying this. Got it? And this is the mass or weight. So you can multiply these two because we know already W is equal to N into M. Got it? Based on this formula. Okay? So you can put 1 into 16, 16 gram. 2 into 32, 64 gram. 1 into 44, 44, 2 into 36 gram. So this is the theoretical weight. Do you understand this? Or theoretical mass. Okay. Now, what is given here? 16 gram methane. So this is the experimental weight. So they are clearly told 16 gram. Okay. Right. So 16 grams, and that should give X amount of water. Put X. Now what you are supposed to do? that is mass ratio. I said W2 by WE. What do you call that? Mass ratio. Okay. So the ratio of these two is called mass ratio, MR. That is nothing but theoretical weight divided by experimental weight is always a constant. So based on this approach, we go, right? So you can take this as the ratio. This is the mass ratio. Okay. And again another mass ratio. These two must be equal. Done. So 16 divided by 16 is equal to 36 divided by x. It means x should be 36 gram. Got it? Okay. Yes, sir. So this is known as mass ratio. So we have discussed the second aspect now. That is this one. Okay. Now let us move to the third one. Weight to mole, that is mass to mole or mole to mass. Either way. They may give mass and ask mole, or they will give mole, they may ask mass, right? Okay. Yes. Now calculation involving mass and mole, that is mole or mass. Take down another sum. Next example. Oxygen is prepared by Oxygen is prepared by catalytic decomposition. Catalytic decomposition of potassium chlorate, KClO3. Okay. If 2.4 moles, if 2.4 moles of oxygen is needed, is needed, how many grams of potassium chlorate? How many grams of potassium chlorate must be decomposed? Do you understand this concept? See, first we have to write down the reaction. What is the reaction? That is, oxygen is produced by catalytic decomposition. Okay. So it means when you take KClO3, that is potassium, what is that? Chlorate. KClO3. And when it is decomposed, catalytically it is decomposed. So it means KCl and the oxygen are removed. Oxygen is removed from potassium chloride. Now we have to balance the chemical reaction. Okay, got it? So this is 2KClO3. So 2 3s are 6. So we can put 3. Done. So this is the balanced reaction. Now let us move to number of moles, theoretical moles. How much? 2 mole, right? Now you can tell me. What about this? 2. 2. Hmm. 3. The next step. Molar mass. Hmm. What is the molar mass for potassium? 39. Chlorine? 35.5. Plus 30. Oxygen? 16. How much? 245, huh? Yes, sir. Right. So 245 gram per mole. Then what about potassium chloride? 39 plus 35.5 you can put. How much? So 74.5. 74.5. What about oxygen? 32, right? Now what you're supposed to do? Weight. right? Theoretical weight. That is equal to, you can multiply these two, is it not? So 2 into 245, how much? 490. Huh? 490. 490 grams. This one? Um, 149. 149. This one? 96. 96. Then 5. Now what is asked here? That is 2.4 moles. It is given as 2.4 moles is needed. Okay. If 2.4 moles is needed, what could be the weight? So that is the question. It is taken as reverse here. So what you can do, that is, now for theoretical one, you can underline that one because it is given as a theoretical one. Okay. So here 2 moles. And what about this? 2.4 moles. Yes. Okay. So 2.4 moles. It is given as 2.4 moles of oxygen. Okay. Yes. Right. So 2.4 mole of oxygen, for which what is asked here? What is the weight of KClO3 required? Correct. Yes. Sir. So the weight of KClO3 is how much? That you can put yes here. Are you able to follow? Yes. So you know very well. Now you can do like this. You need a weight. You know for 3 moles, what is the theoretical weight required? 490, right? Yes. For 3. So you had to go like this. So for 3 moles, you need 490. Therefore, for 2.4, okay, what is the weight? This is weight, okay. So you must remember this is the weight. So what is the weight of this one required here? You have to proceed like this. So what you can do, that is, you can put like this, that is 3 divided by 2.4, and here what is that? 490. So 490 divided by x. Got it? Okay. Now 3x is equal to how much? 490 into 2.4. So x is equal to 490 into 2.4 divided by 3. Now tell me. 392. 3? I'm sorry, just a minute. Here, wait. We have got the weight that is for 3 mole because the weight, this is the theoretical weight, but for 3 moles, the requirement is a 245 because by taking 245 mole, you are able to get what? How much? Yeah, you are correct. Okay, so X can be what? How much? Okay. 392. 392. Okay. So, but this 392 here for 2 moles of KClO3. But when we consider 1 mole, in that case, you can divide this by 2. So, X per mole of KClO3. It means 196. Got it? Yes, sir. Because the 3 moles is produced by the decomposition of how much? KClO3 of 245. Okay. Okay, sir. Similarly, you can calculate the volume also. Let us go ahead how to do with the volume. So we have discussed the this part, weight, number of moles or number of moles in terms of weight. Now the next part, that is weight and volume. So mass volume relationship. So this is the fourth one. Take down the question. Calculate the amount of KClO3 needed to supply sufficient oxygen for burning. Sufficient oxygen for burning 112 liter carbon dioxide. So this is a carbon monoxide. This is the volume of carbon monoxide that requires 112 liter. And this takes place at normal temperature pressure at NTP. So let me repeat. Calculate the weight of potassium chloride needed to supply sufficient oxygen. So it has to supply oxygen for burning 112 liter volume of carbon monoxide at normal temperature. Now we have to establish the reaction first of all. Okay. So in this case, the first reaction is that is a calculation of oxygen required to burn. Is it not? So the first reaction is calculation of oxygen required for what? To burn how much? 112 liter of CO. Okay. So CO is burnt oxygen to give what is that? CO2. So this is the first reaction. Okay. And what is the mole required here? CO plus what? You can put a half mole of oxygen also. Okay. Now this requires 1 mole of what is that? Carbon monoxide. That requires zero point 0.2 mole of how much? Oxygen. To burn how much? 1 mole of carbon dioxide. I mean to give 1 mole of carbon dioxide. Do you understand this? So this 1 mole of carbon dioxide occupies the volume 22.4 liter. This is called Avogadro's volume. Take down. Are you able to understand this? Okay, got it. Now 22.4 liter means that is 1 mole. In that case, we had to calculate the 112 liter of carbon monoxide. So here you had to say, see, this is 22.4 liter, is it not? So 22.4 liter, listen to me carefully. The 22.4 liter of carbon dioxide, okay, 20, that is this much. 1 mole means this is also 1 mole is equal to 22.4 liters. And this is also 1 mole, that is 22.4 liter. So both are same. When I say 1 mole of gas means 22.4 liter, this can be given as ml also, 22,400 ml. Sometimes it is given as cubic meter also, so you should be able to convert the volume accordingly. So this is also known as 22.4 decimeter cube. Okay. If you want to convert this into liter, you have to multiply by 10 power minus 3. So you can put 22.4 into 10 power minus 3 cubic meters. So about which I will discuss later regarding the conversion factors. Okay. Now let me confine to liter 1. So 1 mole is equal to what? 22.4 liter. So let us now consider this equation carefully. You have to follow. 22.4 liter of what? Carbon monoxide, okay, requires how much mole? 1 by 2 means 0.5, sorry. 0.5. 1 by 2 means 0.5. Is it not? Write down 22.4 liter carbon monoxide needs how much oxygen? How much oxygen? 0.5 mole. Zero point 0.5. This one. Zero point 0.5 mole. This is volume. This is mole. Okay. Right. Now our idea is what is given here? 112 liter. So 112 liter carbon dioxide needs how much oxygen? You can put 11, 12. 112 divided by 22.4 into zero point 0.5. So what is the value? How much? How much mole? You will get the result in mole. How much?
So 2.5.
Very good. So 2.5, what is the unit? Mole of oxygen, right? Now we have calculated the 2.5 mole of oxygen, and that is required for what? That is from for suppose if we want this 2.4 mole of oxygen, and what is the quantity of KClO3 required? So likewise, we have to proceed with the second equation. We understand now we have got two equations here. Okay. Now, let us proceed with the first equation, I mean, second equation. KClO3 that we already discussed in the previous problem. So, KClO3, take down KClO3 gives on heating, what is that? KCl and oxygen. So, balance it. So, this on, tell me, heating gives potassium chloride and oxygen. Now we have to balance. Can you balance 2 moles of KClO3? 2 KCl, you can put 3 oxygen, right? So now we have got the balanced reaction. Okay, got it?
Yes.
Now, what is the next step? The balanced reaction is done and 2 moles. So, theoretical mole, 2 mole, 2 mole, 3 mole. Then molar mass, tell me, 39 for potassium.
245.
So, 245 gram per mole. So, this is mole. This is gram per mole. And what about this for KCl?
74.5.
How much? 74 point.
4.5.
This one
32.
32. Okay. Now we have put mass and the next step, what is that? Weight. So 2 into 245. That is 490 gram. So this much 149. And here 96. Let it be. Now what is our objective? We have to find out the this is theoretical weight. This is the experimental weight. Got it? So the experimental weight is how much? That is asked. Done. And what is the experimental weight given for oxygen? Instead of weight, they are given in terms of mole. Do you understand? So here it is given as weight, whereas here it is given as mole. So N you can put experimental is equal to how much?
2.5.
2.5. Okay, so this is 2.5. But here it is 3. Got it? So it means you are able to get 3 moles of, what is that? 3 moles of oxygen from 245 gram. Got this point? So 3 moles of oxygen is obtained from 245 gram of KCl3, right? Okay.
Yes.
In that case, what is our mole? 2 point, tell me, 5 mole. So what could be the weight? So 245 into 2.5 divided by 3. What is the answer?
So, 204.167.
How much? 204.167.
0.167.
This much gram of what? The KCl3 is required. Okay. Not gram per mole. You have to say only gram because we are taken this as gram only. For 3 mole, okay, for 3 mole, you are able to get 245 gram because mole inverse cancelled now.
Okay.
So 245 into 2.5 divided by 3. So it means 204.16 gram. So what is the weight of KCl3 required for this 204.167? Now let me go through once again this problem. Listen to me carefully. Here, what is asked? That is, the weight of KClO3 is asked, and you are getting some amount of oxygen, and for that oxygen, that is, you are capable of getting this 112 liter of carbon monoxide. So we have got two equations now. So what about the quantity of oxygen available from the first experiment is consumed in the second experiment? But what they are given, they are not given directly what? The weight of oxygen or the mole of oxygen. Instead, what they have done, they have taken another reaction and where from they are given the consumption of 112 liter of volume of carbon monoxide. Do you understand? So they have given actually two reactions. What are those two reactions? Reaction number one, reaction number two. Actually, that is, we have done the reaction number two primarily, and we have taken the reaction number one secondarily. But it should have been KClO3 from which you are able to get KCl plus O2. Got it? So this oxygen is used up to react with carbon monoxide to form how much? CO2. Okay. So here they have given the volume of CO as 112 liter. So instead of mentioning the volume of oxygen required here or obtained here, that much quantity is used up to convert 112 liter of carbon dioxide to convert into 1 mole of carbon dioxide, carbon monoxide to convert into 1 mole. So indirectly they are given. So that is why I had taken up the second reaction first in order to find out what is the oxygen consumed here. Do you understand this one?
Yes.
Okay. So there is one concept, it's called a limiting reagent, about which I'll be discussing in the next class. Okay. So now we have completed, what is that? The fourth one, that is volume, weight, volume relationship. Okay. Got it? Now let us go straight away to volume relation. Okay. That is the final one of this class today. Take that. Now we are discussing about volume-volume relation. That is point number 5. Take the question. What volume of oxygen at STP? What volume of oxygen at STP is required to effect complete combustion, complete combustion of 200 ml acetylene and what would be the volume of carbon dioxide formed? So they have asked two questions, volume of carbon dioxide, volume of oxygen. But they are given only 200 ml of acetylene. So this is pretty clear that they have considered only the volume. So it is by volume relation, volume relation. Okay, take down. What is the molecular formula of acetylene? What is the IUPAC name for acetylene? Ethine. Ethine means C2H2. It's a triple bond one. Okay, alkyne. This is called alkyne. That is the first member of alkyne. Okay. Now let us do the balance reaction. Br, what we are supposed to do? C2H2 and then combines with oxygen to form what? Carbon dioxide and water. Okay, take that. And now we can balance it. 2C2. So this is 4 and 2 2s are 4. So it should be 2. And you can calculate 4 2s are 8. This is so 5O2. Right? So now it is balanced. Okay, got it? Now let us proceed with the second one. Tell me now what we are supposed to write. What is that?
Two, five more.
And then 2. And then third one. So these are all theoretical. And we have to find out the molecular weight. What is that? For carbon 12. Now, now instead you can do one thing because there is no weight required here. All are asked in volume only. Okay, right? So now what we can do is we can straight away go ahead with the volume. Okay. So in that case, let us introduce the Avogadro's volume. We can put Va. Okay. So what is Avogadro's volume? That is Avogadro's volume means 22.4 liter. Is it not? Avogadro's volume means 20. This is given in ml. So we can convert this also 22,400 ml. Right? This is Avogadro's volume. Okay. Are you able to follow?
Yes.
And what is asked here? O2. So O2. So what is Avogadro's volume for O2? That is also 22,400 ml. And what is the next one they are asked to carbon dioxide. So carbon dioxide is 22,400 ml. Okay. So these are all the volume. Now listen to me very carefully. Now here let us go ahead with these are all the Avogadro's volume, right? And what could be the theoretical volume here? So the theoretical volume can be, we can put theoretical VT. So 2 into, for 1 mole, 22,400 mol. For 2 moles, so 2 into 22,400 mol, correct? 400 ml. What about this? 5 into 22,400. What about this carbon dioxide? 4 into 22,400. Okay. So now we have the given volume. So what is the given volume? That is experimental volume. What is the experimental volume? 200 ml of acetylene, right? Okay.
Yep. Yeah.
So put 200 ml. Okay. Now what are asked here? Oxygen. Put oxygen X and the carbon dioxide. Put Y. Are you able to follow?
Yes.
Okay. So what you can do? That is this divided by this. These two ratios will be equal. And again, these two ratios will be equal. Okay. So you can do that is 2 into 22,400 divided by 200 is equal to 5 into 22,400 divided by x. So you can cancel this. So x is equal to what? 500 into, sorry, 200 into 5 divided by
Two.
2.
Which is 500 ml.
Okay. So it means 500 ml. Done. So similarly, you can do the next equation. You can equate these two. Okay. Do it. 2 into, yes, 22,400 divided by 200 is equal to 4 into 22,400 divided by y. Okay. So cancel it. Now y is equal to 4 into 200 divided by how much? 2. So it means 400 millimoles. Are you able to follow? So now you can declare what is this X? The X is volume of what? Oxygen. Is it not? So the volume of oxygen at NTP is equal to, you can declare the answer as how much? 500 ml. Similarly, volume of carbon dioxide at the NTP is released how much? 400 ml. So likewise, you can report the answer. Got this point? Okay. So now we have completed all these ratios. Okay. So what are the important ratios? Sums here. You can anticipate many number of problems based on this. So one is N, that is mole ratio. Another is mass ratio. Another is weight mole ratio or mole mass ratio. Fourth one is weight volume ratio. Fifth one is volume by volume ratio. Okay. So you should be able to solve the problems based on this. And finally, there is one important concept called that is limiting reagent. So I will release a video based on this limiting reagent so that you can very well understand. Otherwise, we will discuss in the next class. Okay. So I will give you some worksheet. So you try to work out all those problems. And did you complete the previous one? That is concentration. Huh? Okay. Okay. So you please go through your books also and try to work out the problems based on that. Additionally, I will give some other important problems also as worksheet, right? Okay. Any doubt?
No, sir.
Right. Right.